So continuing on with the example from the previous page, create a 90% confidence interval for the proportion of all U.S. adults who support a carbon tax to reduce carbon dioxide emissions. So here, remember, we're going to take p hat plus or minus z star times the square root of p hat 1 minus p hat all over n. So plugging in the numbers from the previous page, using 1.645 that we talked about earlier, we end up with an interval that's 0.505 and 0.555. Just a couple of notes of caution. Where I see students going wrong frequently is they try to plug in p here instead of p hat to get the confidence interval. You must use p hat. And they write their interval from large value to small value. Remember, intervals always go from small to large. Now, it asks for the 90% confidence interval. What we see is that the complement to this is 10%, hopefully 90 plus 10, or yeah, 90 plus 10 gives us 100. This complement is the 10% significance level. All right. Now, we'll talk more about that in just a moment, but create a 95% confidence interval for the proportion of all U.S. adults who support a carbon tax to reduce emissions. Well, I'll let you do that. Please make sure you practice that. But here is the answer. What we want to see now is, does your conclusion from B agree with the information from the 90% confidence interval in letter D? Okay, so B and D. So let's look up back at B. B says we reject the null, that we have evidence for the alternate hypothesis. Now, if that's true, then when we look at this, we have support for the alternate. 0.5 should not be in this interval. It should not be a plausible value. And we see that 0.5 is actually outside. So that's good. So for this part, yes. The confidence interval does not contain 0.5. Doing the same thing for part E, this is for the 95% confidence interval, which the complement of that is the 5% significance level, because 95 plus 5 gives us 100. Now, when we did the 5%, we failed to reject, and we said, well, 0.5 is still a plausible value. And it is. It does show up here. It's in the confidence interval. So do they agree? Yes. The confidence interval contains 0.5. They should agree, because significance level and confidence interval percentage are complements of each other, specifically when we're talking about here, the note, the duality of hypothesis tests and confidence intervals. So when we compare the results of a 1 minus alpha times 100% confidence interval to the conclusion of a hypothesis test, they will agree if the two-sided p-value is being compared to the significance level of alpha. Otherwise, they usually won't. And this just gives another example here. But it makes sense. As we kind of tie these two ideas together, we should come to the same conclusion. Once again, 0.5 is a plausible value, so it should be in the confidence interval. Because remember, we're trying to get, in this case, 95% confident that we have that true value of the proportion P. And when we looked here, we said, well, we don't have support that it's different than 0.5. So 0.5 is still a plausible value. The 0.5 being this here, the null value. So here in the next example, batting power, it asks you to take a moment and read through it and then set up the null and alternate hypotheses and then come back and check your answer. So hopefully you took a moment to read that, and you see that P is the probability of a hit, or the long run proportion of hitting the ball. He started at 0.25, and one winner, he actually does improve to 0.333, but we want to investigate how he has to convince, let's say, the manager that that is true. So we're starting, the manager knows he was 0.25. Now he wants to prove that he is better. So once again, just the null being that nothing has changed, he still is a 0.25 batter, and the alternate that he actually has improved. From here, we're going to move on to types of errors in the next video.